Good afternoon, friends. In our previous slides, we have find out this value f t is equals to r into alpha and f is equal to v square by alpha, and how we have calculated these values. We have shown this in the previous slides. Now with this consideration, we know these things, how to calculate the tangential acceleration of a link and the centripetal acceleration of a link. Now we should proceed to calculate the acceleration component of a 4-bar linkage. Let's see how we should do the calculation. So the first, if the problem is like this, this is O, this is A, this is B, this is C. This is a 4-bar linkage that's given to us. And what are the things provided over here is omega. Omega is given to us, angular velocity is given to us. Angular velocity is provided in these directions, and alpha is given in this direction. So these are the known criteria. Only omega is given to us and alpha is given to us. So these are the things which are given to us. Now, and for a specific angle theta, omega is given and alpha is given. Alpha is now omega changes with theta. Now we are required to find out the acceleration analysis for the link BC. Now my first step for solving acceleration analysis is that we have to calculate the velocity analysis to find out the velocity of each link. And once we calculate the velocity analysis, then we could easily able to solve the acceleration analysis. So first we should do the velocity diagram, and velocity diagram for 4-bar linkage I have shown in my previous slide. Once again I am showing it. Now first of all we should just find out what are the direction of the vectors. So this is my first direction of the vector. This is velocity of A with respect to O. This is my second direction of the vector, which is perpendicular to it. We all know that velocity of B with respect to A. And so as the link moves like this, it comes like this, and this link will move like this. Basically we have shown you that, once again I am showing. So if this is connected like this, if the links move like this, so it has a tendency to come like this, and as the link comes like this, so this link BC has a tendency to move like this. This I have discussed vividly, so I am not going details to that. This is my velocity of B with respect to C. So my next step for calculation is that we have to find out a fixed point. So fixed point is O and C. These are my fixed point. So what are this? Velocity of A with respect to O. Velocity of A with respect to O. If we shift this vector, this is velocity of A with respect to O. This is my point A. Okay. Now velocity of B with respect to A. B with respect to A. Again we shift this vector. Velocity of B with respect to A. We shift this vector. But we doesn't know the magnitude. And if we plot the velocity of B with respect to C, this is, we just shift the vector. If we plot whose magnitude is also known, we can get where it cuts. We will take the magnitude from there. So this is known as velocity of B with respect to C, and this is velocity of B with respect to A. So this is my point B. So this velocity vector we have done, and we have known all the velocities of the 4 links. Now we should proceed to calculate the acceleration analysis. The acceleration analysis fundamental remains the same. We have to calculate what are the fixed points. First we have to locate what are the fixed points over here. My fixed points is O and C. These are my fixed points. Okay. Now we should make a table over here. Where we should the velocity, the name of the velocities, and then the magnitude should be shown over here. Now if you see, what are my velocities over here? First of all, we should look at what are my velocities over here. First, what are my velocities there? What are the acceleration known to us? First of all, acceleration of centripetal acceleration of A with respect to O. Centripetal acceleration of A with respect to O, this should be in this direction. Centripetal acceleration always should be towards along the linkage. So this is my centripetal acceleration of A with respect to O. So this is my, if you see that, this is my centripetal acceleration of A with respect to O. So now this is my centripetal acceleration of A with respect to O. Now what is its value? Centripetal, we know the centripetal acceleration is equals to V square by R. Now V square by R. Now what is this V square? V square is equals to what? That is velocity of velocity of A with respect to O. Velocity of A with respect to O square by R. Now velocity of A with respect to O means what? Velocity of A with respect to O. If you see over this diagram, that is O to A. That is from O to A. This is my component. So velocity O to A square by R. R is equals to what? The length of the component OA. So this vector is known to us. This vector is known to us. Now we should proceed for the tangential component. Tangential component of A with respect to O. Now tangential component of A with respect to O indicates what? We know that tangential component is equals to R into alpha. Is equals to R into alpha. Now what is R? R is equals to OA. And as alpha is given to us, so this tangential component we can also get it. Now we get the value of the T and O. So if you see that, if you see over here this component FC, we should basically, the concept remains the same. We should shift this vector, tangential vector, acceleration vector from here to here. So if we shift this vector, it will come like this. It will come like this. So this becomes my A with respect to O by tangential component. This is A with respect to O, the tangential component. This component, this is A with respect to O. Sorry, not tangential. This should be a centripetal. Very extremely sorry. This should be centripetal component. So this centripetal component should be A with respect to O, and we have placed it over here. This should be A with respect to O. This is my centripetal component. Now my tangential component is also known to us. So we know that the centripetal acceleration and tangential acceleration always perpendicular. So the and as the acceleration is over here, the centripetal acceleration should be like this. The tangential acceleration should be like this. So this is my tangential acceleration. This is a known vector. This is tangential acceleration of A with respect to O. So these are the known. Now when we join this, this is my acceleration of A with respect to O. This is my acceleration of A with respect to, we know this vector. This is my, if we calculate this, we should calculate and this vector, that this is the acceleration of A with respect to, this is known to us. Next we should proceed for the link BC. Now link BC, what happens? The centripetal acceleration remains the same. It should be like this. Centripetal acceleration of B with respect to C. And we have to mark over here, this is our point A. We got the point A. Now B with respect to C, this is our centripetal acceleration. Now how to calculate the centripetal acceleration of B with respect to C? Now you see the centripetal acceleration of B with respect to C remains the same. That is V, velocity of B with respect to C whole square by R. R is equals to what? BC. Now velocity of B with respect to C. If you see velocity of B with respect to C should be BC, this component B to C, this component BC. So we just put the value of the BC. We should just put the value of this BC whole square by BC. So this becomes my centripetal component of BC. Now if we plot this, now this is my direction of centripetal acceleration. So we just shift the vector. This is a known vector. Perpendicularly we shift the vector. This becomes my centripetal acceleration of B with respect to C. So this is known to us. Now again another centripetal acceleration is known to us, that is A to B. If you see from A to B, this component is also known. That is centripetal acceleration. If we use another pen rather, this is my centripetal acceleration. This is my centripetal acceleration of B with respect to A. This is my centripetal acceleration of B with respect to A. So centripetal acceleration of B with respect to A we can also calculate. If you write over here, centripetal acceleration of B with respect to A. Centripetal acceleration of B with respect to A. Now one thing is that we cannot centripetal acceleration of B with respect to centripetal acceleration of B. We cannot find out the tangential component, we have to discuss over here little thing. We cannot find out the tangential component of B with respect to C. Why we cannot calculate the tangential value of B with respect to C? Because BC is known to us, but alpha is not known to us. So we cannot calculate this value. So we leave it over here. So we have gone to this component A to B. Now when we go from A to B, what we'll get? The the centripetal component of B with respect to A. So can we get this vector? Obviously, because it is velocity of B with respect to A by AB. Now velocity of B with respect to A. Now velocity of B with respect to A, is it a known vector? Velocity of B with respect to A, this is, we can find out this is the velocity of B with respect to A. This is the value of B with respect to A, that is AB. So we'll just take the value of AB square by AB. So this is also known to us. So we just shift the vector. We just shift this vector, that is this vector over here. We just shift this vector over here. So this becomes centripetal acceleration of B with respect to A. Centripetal acceleration of B with respect to A, this is known to us. Now this is our known vector. Now what we should proceed? Now velocity of B with respect to A is our known vector. So this is also known, because why? This is known, as we have seen, velocity of B with respect to C, acceleration of B with respect to C. How we should get B to A, as I've shown it, acceleration of B to A, this is a known vector. So we just put it. Now what we should do next, our step, as we know that all the components, tangential components, centripetal components are perpendicular, so we draw a perpendicular line. We'll draw a perpendicular line from each of this. We'll draw a perpendicular line. So if we draw a perpendicular line from here, we will get where these two perpendicular line cuts. This will be marked as the tangential component of B with respect to C, and this will mark tangential component of B with respect to A. Now when we join these vectors, when we join this point, that is B with respect to A, this is the acceleration of the component, and when we join B with this point, that becomes the point B, that is we will get the component of B with respect to C, because that will get the component of B with respect to C. This component will become B with respect to C. So this is my B with respect to C. This is my tangential component. This is my centripetal component. When we join this, when we'll join this point, we should this is the point B. We'll get the tangential component of B with respect to C. So now these points, the acceleration of A with respect to A, we can calculate acceleration of B with respect to A, we can calculate an acceleration of B with respect to C, calculate. So we have calculated all the acceleration of the four links. Okay, and this is the very easy way to solve it, to solve the problems. First, we have to keep in mind, we have to know the velocity analysis, then we should proceed the acceleration analysis. Okay, thank you. That is all about from this part. So if you like my lecture, please put a like mark to it. Thank you.